Hello students, today we are going to study a very important topic in mathematics, the binomial theorem. This theorem is not only useful in algebra but also in probability, calculus and combinatorics. Let us begin. The binomial theorem has a rich history. It was first introduced by Al-Karaji in the 10th century. Later, Isaac Newton extended it to non-integer exponents, which laid the foundation for infinite series.
Sir, why is Newton's extension so important?
Good question. Newton's generalization allowed us to expand expressions like 1 plus x to the power n, even when n is not an integer. This became the base for calculus and Taylor series expansions. For any non-negative integer n, a plus p to the power n equals the summation from k equals 0 to n of n choose k multiplied by a to the power n minus k multiplied by b to the power k. Here, the term n choose k means n factorial divided by k factorial multiplied by n minus k factorial. This is called the binomial coefficient. There are two common proofs. First, proof by induction. Base case for n equals 1, a plus b equals a plus b, which matches the formula. Inductive step, assume true for n, then prove for n plus 1 using expansion and binomial identities.
Sir, do we need to write these proofs in exams?
Yes. Proof by induction is often asked in higher exams, while the combinatorial proof builds strong understanding. Second, combinatorial proof, the binomial coefficient n choose k the number of ways to choose k elements from n each term a to the power n minus k multiplied by b to the power k corresponds to choosing k times b and n minus k times a. Properties of binomial coefficients. Some key properties: symmetry, n choose k equals n choose n minus k, sum of all coefficients, summation of n choose k equals to the power n, alternating sum, summation of minus 1 to the power k multiplied by n choose k equals 0. Pascal's identity, n choose k equals n minus 1 choose k plus n minus 1 choose k minus 1. The binomial theorem is used in many areas in algebra to expand powers of binomials. In probability, it forms the basis of the binomial distribution. Probability of x equals k equals n choose k multiplied by p to the power k multiplied by 1 minus p to the power n minus k in combinatorics for counting subsets and arrangements. In calculus, for Taylor series and Newton's generalized expansion. For absolute value of x less than 1 and any real number n, 1 plus x to the power n equals summation from k equals 0 to infinity of n choose k multiplied by x to the power k. Here, n choose k equals n multiplied by n minus 1 multiplied by n minus 2 up to n minus k plus 1 divided by k factorial. A generalization of binomial is the multinomial theorem. x1 plus x2 plus up to xr to the power n equals summation of n factorial divided by n1 factorial n2 factorial up to nr factorial multiplied by x1 to the power n1 multiplied by x2 to the power n2 and so on, where n1 plus n2 plus nr equals n. In number theory, Fermat's little theorem states that if p is prime and a is not divisible by p, then a to the power p minus 1 is congruent to 1 modulo p. Lucas' theorem helps compute binomial coefficients modulo a prime. Students often make mistakes like forgetting that expansion for real exponents is infinite. Misusing binomial coefficients in modular arithmetic. Ignoring convergence conditions for infinite series.
Sir, how can we avoid these mistakes in exams?
Very simple. Always check whether the exponent is an integer or not. Carefully apply formulas and practice examples. Let's try one. What is the coefficient of x cube in the expansion of 1 plus x to the power 5? Correct answer is 10 because 5 choose 3 equals 10. So students, today we learned the history, statement, proofs, properties, applications, and even mistakes to avoid in the binomial theorem. With practice, this chapter becomes one of the easiest and most scoring in mathematics. Jai Hind.